Lots of planets have a north. Hello and welcome. Let me find a camera here. Damn, this is going really well today. Really well. It looks very much like my ISP is still having problems even after I solved the first one for them. I hope this is somewhat bearable. There are a couple more things broken now, like for example the camera switching seems to not work. It's there we go. Anyways, still hello and welcome. We're still gonna do this. I still want to get a few things done today, and I thought I'd bring you along. Yeah, usually this stream, if you're interested in joining one and you see this after the fact, Saturdays at 7 p.m. Central Europe time, 6 p.m. UK, 1 p.m. East Coast, and 9 a.m. West Coast for all of those early birds. Yeah, what are we doing? We are building this. Well, actually, we built it, we already printed with it, then I printed some more with it, and then I destroyed it. Well, it destroyed itself, or it was probably both our faults, because if you have seen the last stream that I did on building a controller rig for my Asus ROG Z13, I had the printer cam running in the side, and you can basically watch how the print is failing. It seems to have some boogers in the first layer. Those get picked up by the silicon sock, and yeah, and this is by the way the first thing we want to talk about. But before we get to that, if you're in chat, say hello. Let me know that you're there. If you have any questions, let me know. Let's have a bit of an easy stream, bit of a chill stream here. The way we're going to fix the problem is going to mean that we do need to print some more calibration things. We're also going to mount the panels. We're going to deal with the Nevermore that you can see here. That's going to get its power delivered today in a crimp and solder session. We're going to mount the panels, and we're going to prepare this printer basically for printing ABS, so it can function as a replacement for the Trident in the pinch, because then we can actually do some really nice shit to that Trident. That's the plan anyways. We're going to see how that goes. We're going to see what that does. But I'd say first things first. Let's get into it. Let's get this started. Let me check my camera setup here real quick, because I tend to have things hanging in front of the camera, as you may have seen. One other topic as well, we're going to go through the steps of securing your printer again once you have it set up, because last time the microphone cut out, and while you can see this as a silent movie on your screen, there is so much information in there that I think you should be looking at, that I'm just going to go over the setup again and walk you through the steps of how to securely connect the printer like this with some funky Chinese operating system that may have had modifications, how you connect that to your network. On my end, I already moved on to now having this connected wirelessly to a separate network, but yeah, you can still, I think you should still go through the motions of setting this up properly and having this connect to your network without an internet connection. And we're going to look into that. Yeah, those are the topics that we're going to cover. We may not get to all of them. It's a bit of a I'd say difficult day for me in terms of getting stuff like that done, because I do have to travel to London tomorrow, and my train in this case, because a colleague of mine is afraid of flying, and I'm holding in his hands so he doesn't also get off the train before he reaches there. Yeah, so that's what I have to do tomorrow, and that obviously means that I can't stream 8 hours today, which was never the plan in the first place, but you know how things go. Yeah, cool. Let's get into it. I'd say let's talk about how to secure your printer later, while we do some test prints. We're gonna move this printer to the side once we're ready to do some test prints. Let's fix the hot end first. And for that, and for you to understand what happened, I think I need to show you the what the hot end looks like now. Let me fix that. There. So what we have here, let me see if I can improve on the focus a bit still, and the clarity here. What we have here is the heater block and the nozzle of the old hot end. Now, if you look at this, if you look at this silicone sock, you can see that it barely gives any room between the nozzle tip and the rim of the silicone sock. Now, if you're printing cleanly, that's not a problem, right? Because you don't have anything in the way. But if you're like me, printing something really large, in this case these hex holders that I want to use to mount some things to the side here, and you don't print a skirt, then you run into a few issues. Also, then you basically get your buggers, your oozing in your print. This can result in some higher parts of the print, and those can catch on your nozzle. But your nozzle usually follows paths that you want, or it can catch on the silicone. Now, why is that? Is that something we should concern ourselves with? I don't know. I'm basically not sure whether this is correct this way or not. But if we look at my favorite hot end at the moment, still, the Dragon hot end, we see that there's between the tip, and this is at the moment, I guess, potentially a rather large tip, and the silicone sock, there is way less space. If we hold those together, the silicone sock of the Fysetc heater block is about 0.5 millimeter to even 1 millimeter higher than the one of the Dragon hot end here. Also, this sock sits way more securely. It sits way more snugly than this. So what happened in the build is, or in the print, is we had the buggers. It caught the silicone sock. It swooshed the print from the print plate, got caught in the silicone sock, and because it is really loose here, right, and it's not actually all that hard to do, it caught the silicone sock and just ripped it off slightly, got it at an angle. And it got it at such a bad angle that the that the nozzle was covered. So the whole print, like not sure if you can see this, but something like this, right? And the result of that was that the whole print was done inside the silicon sock instead of outside. Now you see that I already cleaned that up somewhat. You can still see the residue, but like this is useless now. This is useless because, and you should never use something like that again without properly cleaning it up. And I think properly cleaning it up is just impossible because the plastic is oozed inside here between the thermistor and the heater block, and between the heater and the heater block. It probably also cooked somewhat in here, and even if you can heat this up again and get it out, I doubt that it's worth it. So what we're going to do instead is we're going to leave this. We're going to ignore that they exist, that exists and that happened. And we are going to just simply put in a new Hotend. This. And yes, this is a special tip. This is actually a diamondback nozzle. It's also a 0.6 nozzle, not a 0.4, because I don't have another 0.4. I could use the default nozzle that comes with these, but yeah, I just want a diamond. The other option would have been to use a proper Hotend. I have a 0.4 diamondback for, which the only other one I have is an MK8. So that would mean we would need to put the spider in here. But I kind of want to have the spider in the salad fork. It's, let's put it this way, it's the part I trust least. And since this is supposed to be a replacement printer or like an emergency printer, it needs to have a reliable nozzle, and I think a 0.6 is just fine. 0.6 is just fine. It's just gonna do just fine for the hex grid. It's going to do just fine with everything else. Arachne slicing should take care of most of the issues here. This one I'm gonna throw away, but I am going to keep the Hotend on account of being able to just source another heater block and potentially popping that in there, having another go at it. Because to be honest, this silicon sock is shit, but I was pleasantly surprised by the throughput of this Hotend heater block and nozzle. It already lost some of its plating. You can maybe see it here due to all the plastic sticking to it and me taking it off. But otherwise, this actually did pretty good. Yeah, so that's what we need to fix. We need to get the Hotend out, swap in the new one. Luckily, and this is something that I really like about this kit, the replacement is just a... Hey Jacob. Yeah, happy to have you. So this is something I really like about this kit. It actually has the same mounting holes as a performance upgrade. So we don't need to print new parts. We don't need to do anything else. We just pop the other one out, this one in, run some flow calibration, and that's it. That's basically all we need to do here to repair this. I'm still a bit bummed at the quality of the original heater block though, and it does cost me some additional crimping time and a few things. So yeah, let's go. Let's do that first maybe. Let's move to the top cam here, and this looks very much zoomed in, so let's put that out. And let's get this on the table. Well, actually, that might work. Let's see how that goes. It's a bit funky, but we'll figure it out. It now rests on the spool holder. Yeah, there you go. It's not actually stable, so I'm gonna do it this way. Yeah, due to this whole thing, I'm very much guessing the review of the kit will have to wait, because we can't even do the input shaper tuning this stream likely. We may still get to it, but we'll see, we'll see. There we go. Those two are out. No, the 4 in the back. And as I discovered, I should actually be able to... No, these don't fit. Where do I have one that fits? Here, maybe. Jacob, since you're here, let me know how the stream is. I had some pretty severe issues with the with my ISP earlier that resulted in more or less 95% of packets dropped. I see on my end that this is better now, but or it's supposed to be better now at least, but obviously can't be sure. So to make this easier, to get easier access to the screws in the back, we will need to open up our top hat, and I hope this is the correct one. Yeah, that looks good. The question is, how did this open? Which one? There we go. So, and now we can actually get this unscrewed. Oh, and I'm still only watching top chat. That's obviously not what we want to do. There we go, that's better. That is way better. Yeah, in general, like the first 2 prints on this printer were pretty good. I was actually really impressed by the speed it could already push without being fully input shaper calibrated. But that last print it did was a bit spicy. There we go, that takes care of the electronics. And then there's one more screw in here in the back that we also need to take off. And that's that. I am not going to remove the cables because it's just strictly not necessary. Due to how this is designed, I can just take out this more or less quick release. I would have actually liked to be able to do this without even taking off the electronics, but that's actually not possible. And now we're just gonna pop in the new Hotend. This, by the way, being the Dragon Hotend adapter, so it's already the correct adapter for the Hotend we're gonna use. That's probably why Fysetc chose it. The Dragon Hotend itself is actually discontinued. That was discontinued by Fysetc earlier this year, I think, or late last year, which is really unfortunate because it was like a bit of a fan favorite, although it was kind of over-engineered with it being able to reach 500 degrees in temperature and printing in 500 degrees in temperature. So not sure whoever needed that. Okay, so we're gonna keep that. And now we're just going to put in our new Hotend. So this points to the back. We want this to point to the front, I think. So this is the way. And no thread locker, no nothing. Just to put that in here. Because obviously these are high temp components, and your thread locker wouldn't do anything anyways. Also, we don't want to completely tighten that down yet, so we can fit all the screws without running into any stresses here. There we go. The next thing we need to do is find our stubby here, because I already prepared this part in terms of length. It should already fit perfectly in here and leave a 6mm stud. But we are going to measure that if I can find my calipers, just to make sure it's roughly in spec. This is roughly what we expect. Yeah, that's perfect. So next, the Hotend is off. We need our other favorite screwdriver. Let's use that one. And then we need the Thermistor loosened as well. And it looks like the stream is improving, so I'm not that worried anymore about it. What I am worried about still is the nozzle here. So, well, I do want to tighten that some more once it is actually heated up. I am going to pre-tighten this as much as I can. So there. I'm gonna put it in this way. So we want all cables to come out the right side. And since I had to order a new heater and a new thermistor, I got this frickin' long wire here. We're obviously not going to use that. Just going to pop that in there with the wires side by side because we want to bend them up. Right, we want to actually bend them up this way. Then we're screwing them that in. This is a big heater block though. This should have been shorter. I don't like this. I don't like this. No. Let me check this one as well. Yeah, that's actually the correct length. What the hell? No, this is... Oh, this is the... Damn it. Okay, then we're going to go into our secret stash here. Yeah, that fits. And we need to... We need to grab the heater from a different printer. This was meant to be another project that we're going to get to later. Nicest colors ever. I'm really looking forward to this build. What the hell? Oh, here, larger screws. Oh yeah, these are actually socket heads, so where do I have the driver for that? That's too large. Is it this one? No. Where do I... Well, let's just do this really simply. This is the only driver I have at hand for this socket. So yeah. Nice, so break this loose. There we go. That should do it. Because I used socket heads here for the extra torque, and because I had stainless hardware for it, which I did not have available for button heads. And this kit is hopefully going to be built in mostly stainless hardware. Anyways, more or less same deal here. You can just pull that out. And now that I have this out, just going to take this out as well. I'm probably gonna need to at least loosen these two. There we go. That should do. And of course now that's loose, so let's pop that out real quick. Now I dropped something, probably one of the screws. I'm gonna put this aside for a moment. It's enough that we cannibalized it. Don't think we necessarily need to put it together again. 1, 2, 3, 4. This is the other one for here. I'm kind of tempted to put in the yeah, let's do it. Let's put in the Creality Hotend. Put that aside. And I can't see the screw right now that we dropped, but oh well. So this is going to be an interesting one because we need to recrimp this, I think. And we need to take this off. I hope it is long enough. Yeah, this is going to be really interesting then. So instead of a Fetus Dragon Hotend, we're going to use the Creality Spider 3 Pro. This little one. It is meant to essentially have the like similar properties to the Dragon, but yeah, who knows? This is from a Chinese manufacturer as well, from one of the how should I put this, budget or more budget vendors. So it is going to be a bit of an adventure to see what that actually does and how well it does it. We are going to lose a couple of millimeters of print volume here, because this, or let me show you this here real quick. There is a difference in height between those two. Move that aside and that. So if we look at these side by side, the MK8 nozzle is a bit longer, although the heater block is shorter, so we may end up at roughly the same height actually. We'll see. This is very much an experiment for me as well. The only reason why I'm using these instead of the Dragon is, again, because I still have one of these nozzles, and these things have been really good to me. And with really good, I mean really, really good. but they're freaking expensive, so I'm not gonna. I have a set of MK8s that I bought initially. I have a set of V6, and unless I move to Revos sometime soon, I'm not gonna change these. I'm not gonna buy any more of these because it is insane what these things cost. Because they're industrial diamond tipped, and that makes them not be cheap. So, but we wanted to check our cable length here. So let's pop that in. That looks good. Although I'm wondering if that's the correct direction here. Because I would assume that you want the Creality logo to face the front. Yeah, let's turn that around real quick. Oh wait, we could actually check documentation here. Might be the thing to do. And let me see if we can get a browser up here. Yeah, there we go. And we want the we're just going to look at images. I'm still not sure why the hell Google decided to let me look at this stuff in German again. But you know, it is what it is. Let's just check if we can find a mini stealth burner with a properly installed one. Yeah, so the stealth burner seems to mount the. Oh, we could actually check the Voron manual as well. Let me take you along there, because I think the Spider Hotend was actually one of the officially supported ones. Huh. Look at that. It's actually the right way around if you compare it here. They do have the beveled side here. So yeah, let's keep it this way. Let's keep it this way. No sense in making this any more complicated than it needs to be. What we want to look at though is fit of the cable. If we do this and there, and I really want to clean these up, so I'm actually tempted to take off this extra sleeve here, because I really don't like these sleeves. But first we need to cut off the connector here, because we obviously don't need that Then we're gonna strip this. And that's where our wire strippers are already running into issues. There we go, that stripped quite well. I am not going to crimp this, I think. I'm just gonna screw that down directly. Although, I think we should actually. There we go, that's the second one. Make this a bit pretty. And yeah, let's cut off these this tangled mess here. There we go. Tangled mess mostly gone. The problem, of course, with these tangled messes is as soon as you cut these off, you give new tangled messes room for developing. So we will need to also get this reasonably close to a lighter in a second. Hopefully without burning down the house. Hopefully we can manage to not burn down the house. Yeah, if you're in chat, let me know. If anybody has questions, just ask. I'm here to answer. Otherwise, I'm just gonna continue mounting this. I'm just gonna continue working on this as fast as I can, because, well, obviously, need to get a few things done. Today. There we go. The interesting thing here will be to size these ferrules so they still fit our tool head board. These are already too large. I think I need white. Yeah, white might be the only way to go. And to be honest, I have never crimped these, so this is going to be a bit of an experience for me as well. We'll figure it out. We'll figure it out. So finagle these in there as best as we can. Little pull test. That's actually pretty solid. I like that. I like that very much. Let's do the other one. I noticed a distinct pattern here. I'm going to try to crimp this one the other way around, because I think the pattern I saw previously on the pin on pre-crimp wires and not on the ferrule. We'll see, we'll see. Well, it still ended up on the ferrule. I guess that's the way it needs to be. Now this is the part where we need to fix our itty-bitty wires in place. This is what people mean by gaslighting, I guess. Why is that not working? Well, the other way to do this would be to glue those down. I think that's exactly what we need to do here. Just glue those down. See what happens. Because I do not want these to fly around and look ugly. It's not the best idea, I guess, but this is why I hate braided wire. This is exactly why I hate braided wire. Sorry for the noise, I had to get the adhesive off my fingers. I wasn't thinking it would shoot out this badly. But yeah, that gives us that. Now we also need to replace our little heater. Let's just put that aside first. And close the glue, because otherwise that's a recipe for disaster that I am predestined for. Yeah, I guess it's fine. We need to take that off as well, because we need to recrimp that to a different connector. And these wires are frickin' thin, so I need some magnification on these. I'm not even sure I stripped them. Yeah, now I'm sure I stripped them. These look good. And we need our JST crimper. This, of course, not being a PA09 or anything, this just being some really cheap stuff that has been doing well for me. Costs not even half of the price of those, I guess, venerable CO9s, and it's doing pretty well. Doing pretty well for me so far. What else? We need to find the crimp connectors. We need to find the crimp connectors. Let's look for those. This looks like a box we might need. And here are crimp connectors. There's the fan we were searching for last time. Just going to leave that stuff where it is. And we are in need of these smaller ones. Oh, the pressure. Oh, the pressure. Not only is the cable of our thermistor really, really short, but we also, I think, only have this. This looks like the wrong size already. Let's see here. Yeah, that's the wrong size. So we need to actually that's a good question now. Is this the correct connector? Because I don't think it is, and I don't think we have any here. I think we will need to salvage one from the connectors we still have. Ooh, that might not be the best thing to do here. This should be the connector we need, and that is significantly smaller. So Let's see if we have another connector in the other box, because I'm not the most fond of the idea of taking it off this specific fan yet. And I remember salvaging some cable. This is the fan we want to use later. Now we're just gonna go completely ghetto and take that connector off. Oh, Enik. Oh, Enik. Wasn't that? Somebody had a bit of a play with my other thermistor. I don't mind. It's not that bad. Okay. It is your time to shine, little connector. This is actually a non-destructive operation anyways. I will switch you to the front cam though, so you can actually see what's going to happen here, because we need to clamp the connector in the vise here. So we have two hands to do this. I can also actually, let me get you really close, really close to the action. There you go. Got that screwed in. I'm going to use my magic glasses here again so I see a bit more of what's going on. And then we're going to push down the pins, pull up on the tabs, and try to finagle the crimped connector out of there in one piece so we can reuse it later. They're depinning tools and they would probably save me lots of time here, but well, this is the best I can do. Oh, damn it. There you go. That was number one. And this, by the way, being why people hate JST connectors. Because they're just stupid to pin and depin. But with a bit of patience, just a bit of patience. It still works. And for some reason my sound today is broken as hell as well. Let me try something here. Let me see if I can lower the system audio without impacting the audio from for the stream. Yeah, looks like it. Cool, that's good. Anyways, we depinned our connector, so we can now reuse that. I probably would have had some somewhere as well, but just being able to reuse this one saves me a bunch of searching. Now I need to make sure that I have the correct pins, because those are obviously these they obviously got mixed up here as well in all the chaos. Yeah, these are the right ones. These are the right ones, and there we are with the pressure, because we have 5 left. Can we do this with 5 connectors? Also, let me get you back here. Let me get you back here. There we go. Now we're going to crimp these. And this should be reasonably easy now, since these cables are super thin. The most complicated thing here is probably to make sure that I don't push it through too far. That looks solid. The other one. I think that should do it. that was actually pretty good. Since these do not have any polarity to them, we can just push them into our salvaged connector as soon as I spot it again. And that should be that then. These freaking small connectors can barely make out where the taps are. But yeah, it always pays to use as many helpers as you can. If you need a tool to do your job, get a tool to do your job, or to do your hobby stuff. Nothing's worse than trying to do something with the tools that are just not suitable to achieve what you want. Awesome, that's in there. So we have ferrules on this, we have stuff on the other one. Our adhesive is hardening. I guess we can reassemble our Hotend. We're just gonna move the printer further here again. I'm gonna insert our Hotend holder and get our wires bent. I'm only going to zip those down once we have everything in place, because these may be a bit short. So for now we're just gonna mount our Hotend here again. By the way, if you want to see something up close or something, or know something, let me know in chat. If anyone finds this video or is in chat and thinks I'm doing things wrong, let me know. I am not the authority on this stuff. I am doing this as a hobby, and I may not know the first thing about what I'm doing here. Well, I probably don't, because it's so far removed from my expertise and field of work that I would expect that to be the case. Okay, that is interesting. Pull that back all the way. I'm basically getting some resistance from the cable that still needs to form properly into its channel here. That's pushing the Hotend carrier the wrong way. So we're first going to Get this sorted. It's going to make finishing the wiring in the back of the mini stealth burner a bit more complicated, but yeah, well, at least we can check the wire fit, because I do think we have a problem here, and I do think I need to actually turn around the heater cartridge, because it will otherwise not reach its intended plugs. There we go. I do want these cables to go through the middle here. I would want this for this cable as well, if we can make that work. I think we barely can. No, they both need to go to the other side, otherwise they're not going to reach. They're just too short. And we need to still, just maybe so you can see this. If you look at this cable here, it would need to go around here, and its green plug is on the other side. Basically, so yeah, the other side it is. Still going to be tight. There's still not going to be too much wiggle room to get anything else sorted. I'm so curious as to how this nozzle will, this Hotend will do, because if it works, it actually opens up a bit more customizability for me for printers in terms of nozzle size, because way back when I bought a set of 3, a 0.4, a 0.6 and a 0.8. I realize now that I should have gotten the 0.4, the 0.6 and the 1, because if you're printing at 0.8 already, going from 0.8 to 1 doesn't make much difference in terms of the outer structure. You will have nice and thick layer lines either way. But if you want a 1 specifically, if you want to go as big as possible and as fast as possible for a really large print, then having a 1 versus a 0.8 can make all the difference. So yeah, if you're ever in the market for a set of these, get the 0.4 because it's standard. If you really must, you can probably skip that and just get the 0.6, to be honest. That works just as well. Yeah, get the 0.4 if you really must, but otherwise definitely get the 0.6 and definitely get the 1. That's a really nice compromise of a set. That way you don't need all of them. Should save you a pretty penny. What I'm really curious about with this Hotend specifically is why there is, let me see here if I can show you this, why there's only one screw to hold in the large heater cartridge. But there's actually 2 screws to hold in the itty bitty thermistor. Curious. Who knows? Who knows? Oh. Oh. Wait a second. I think the thermistor for that Hotend is just fine, but the heater cartridge I got there is actually too short. And if we remember the cartridge we got from our emergency order, that one was actually too long. You could probably use either, but yeah, nah, that's still too long. Then let's rather use the shorter one. Let's rather use the shorter one. Yeah, it's actually not that short, it's just caved in at the front. All right, cool. Making sure that these really are in there because they're going to expand to some degree. This is going to be such a fun experiment. Just to see what this Hotend does, because I have no freaking idea of what's going to happen here. I can try the wiring here though and see where that needs to go to be enough. We're going to just take off the cable tie there. And then we're going to test that. That's going to work. And test that. That's also going to work, but both barely. So we're going to just fix those in place. Put them in. And yeah, and then deal with the rest. So, oh, and you obviously can't see shit. So the challenge here will be getting these two barely long enough cables to their destination. That's going to be a bit of a pain, but we're gonna make it work. Get that through there. Last chance to sort some cables here. So I am going to make sure that thermistor wire runs on the inside of the heater, so we have a bit more room to move that cable. Then I can actually already plug that in. What a pain, I tell you. There we go, that is in there. Nice. That cable can go right around there. Now the only other thing we need here is a small screwdriver. So we can fix our ferrules in place for the heater. And since the direction here doesn't matter, you can actually plug them in either way. And I think we got barely lucky. That is really freaking tight. That is really tight. Yeah, there you go. We did it. Let me show you up close here in case you're interested. There we go. Ooh. Go away. There you go. So that's our new heater connection. It runs up the side, has this little kink here, goes right into the terminal block that actually is screwed on, sits in there pretty well. Maybe we can give it another quarter turn just to compress that a bit more. So there. And Then we have our thermistor going up here. I think the thermistor connection was crimped pretty well, and the ferrules here as well. So the heater and everything should work. Now we can press this into the channel and finally pull this tight. We want to angle this away from the back so it doesn't interfere with the carriage. Snip that off without wearing glasses, because that's totally safe. That's totally safe. No, I should obviously have worn glasses there, but yeah. Let's pull these tight as well. Angle it away. Again, we also don't want to see it on the front, so we're just gonna try to get it as far. Well, actually, this one, I should have looked at the direction. We're just gonna keep it this way. So there. And then we are going to run these from the bottom. From the bottom in here. Let me zoom out again. Bit shoddy, the camera work, a bit shoddy, but yeah. And now we can just screw that back in. Let's use that one. Damn screw here. Can't get the screwdriver to seat. Let's turn it around just a tiny bit. There we go. And that is in there. That is well in there. Let's maybe push the back into place. Move that to this side.
Fight for me. I may have lost my light. You're the one to make things right. Start over again. Shine for me. If color
There we go. And now I remember what I forgot. There we go. That finally solves the issue. I had forgotten to turn on one of the lights that I have here, so you guys get a better sense of all the directions and what's happening. And I was getting some weird shadows. Should be good now though, should be good now. What's not good, or what at least I don't like as much, is the resistance I am getting here for the orientation of the toolhead board. I hope we didn't clamp any wires anywhere. I'll have a look. I'll have a look. And the last screw. Guess I need to turn you around a bit. So I can actually see what I'm doing. These go above, these go above. Oh, come here, you. And that looks good. I don't immediately see pinched wires. Although I don't like how those wires shoot out from the bottom there. I want them from the side. Well, actually it should be fine. There's enough space there. Let's keep them. Let's keep them that way. That's in there again. The risk there, by the way, being that if they're too loose, they could rattle around and shave themselves off on the... Uh-oh. Uh-oh. Yeah, that's no good. It needs to come off. The wires could shave themselves off on the PCB. Don't think that's necessarily a good idea. But also I just discovered a wire that came loose I'm guessing it's one of the crimped ones that we crimped for the, not for the thermistor because those were freaking solid, but I think it's one of the fan wires. And that's no good, obviously. We need our fans. We want to print our basketball at some point. We want to print our basketball. And we're already almost 2 hours in. Well, 1.5, because first half hour was me dealing with my connection. So let me see here. That looks like a wire broke. And that is no good. Now, the question is from where? I think I can see it. Yeah, it's our center connector, which means it wouldn't necessarily have been a problem, because if you remember, that one wasn't used by the design anyways. The thing is, I was going to set up the filament sensor config, and for that obviously we need that to work. So this is going to be a bit of a challenge. I'm actually I'm not gonna deal with this. I'm not gonna deal with this. The problem is that our connector here, if you look closely, the left pin was what we already had a problem with, that was already broken off. The right pin I just snipped off, and I snipped it off very close to the connector because I need the cable length to still be sufficient on the printer itself. It's a bit impractical, but it is what it is. And then we're just going to recrimp these. Now you're gonna ask, or you may ask, hey Paul, how are you gonna recrimp these if you don't have any more connectors and you can't easily salvage this one? Well, we're gonna steal another one from a fan that we're not gonna use. So that's the plan. That is the actual plan. There we go. But before we do that, I think I will give my little Anik something to eat, because he has been patiently waiting for it as part of his training. I'm just gonna quickly fill his bowl and let him have something. And something to drink, because obviously the dog has priority. The dog, as hard as it is, but the dog has priority over the printer. Okay. There we go. Now depinning, same deal as last time. Gonna move the printer out of the way again. So, oh no, we are actually going to use the mobile cam again. Have that squarely aimed at our vise here. And I hope I don't screw up any of those connectors, otherwise we will need to solder as well. And that's gonna suck. There we go, that looks good. Move you over, there you go. Need to see a bit more. And these are so freaking fiddly. They really don't want to come out. They really don't want to come out. Why don't you want to come out? It's always a bit of a challenge because obviously you want these to still be intact once you're done. So you can't actually be too rough with them. And I'm likely also not the best person to do this. Because my motor skills here are sorely lacking, to be honest. There we go. At least the dog's happy now. At least the dog is happy. And I can't get the damn things out of there. Do I really not have another of these connectors? Apart from the broken one, of course. And I'm pretty sure I still have some, but I would have no idea where to look at right now because they're not sorted into my usual stash. Because they're in a non-common size for me. And it does not look like we have any more besides that one fan that we may still want to use, although I think that one will get another connector as well once we move to the SHT36 toolhead boards. We'll see, we'll see. Anyways, if you're here, if you're in chat, say hi, say you're there, annoy me with questions. If you see this past the fact, give us like, share, subscribe, and let me know what you think in the comments. In either case. Well, actually, the comments, if you're not here already, I'd rather have the have a conversation with you now. Okay, so this was not working well. Let's try it again. Seems like it's our only option to depin our second fan. Wherever I put that now. I think I actually threw that in the box. There we go. So let's try that again. I'm removing the bumpers here. Let's see if we can get some better access here. We'll need to be somewhat careful though to not crush this connector. That would be bad. And I'm also going to use the actual pin we had. I had that in hand earlier. Here we go. This should have an actual pin. Like that one. Might be the thing to use here. Right tool for the job and all. Now we need the rubber baby buggy bumpers here. Otherwise our connector's turning. Whew. Crimpin ain't 80 was the realization of the day, right? Well, deep pinning ain't easy. Probably more along the truth. And these are in there good. They are in there very well. Now I'm going to try to deep pin the other ones. Maybe those give way faster. Although these are going to be somewhat problematic in that they are... It's probably very hard to get at them, to pull them out. Well, maybe not. I don't believe it. I don't believe it. I thought these would be way harder than they actually were. So we got ourselves a connector. Thank you. Now, the next challenge. Repinning them. And now we only have 3 left. So we need to be extra careful that we do this correctly now. And for that reason alone, I'll use my handy dandy glasses. And I'm not gonna disassemble this in any way. I'm just going to print that right in there. Still turning that around a bit makes sense. That should do. And now for the second one. And that does not want to go in there. That ain't good. Because obviously you want to crimp the housing first. So let's maybe try to fit it and then crimp it. And that's way easier this way because this wire is barely at the edge of what you can use these connectors and this crimp size for. So they actually stay in place. In many cases your connectors don't stay in place until you actually crimp them down. Something I do notice about this crimp connection though, it looks as if it crimps the housing twice and the cable not at all, so we're gonna have to take that off and do it again. Needs to be good, needs to be perfect, otherwise we have a sketchy connection. And that's not going to be any good. Also, we still have one of these left, so let's use it. Let's use all the power we have. And let's hope we don't screw this up, otherwise we're not going to have a filament sensor. Boo-hoo. And I lost it. There we go. Maybe fit that here as well now. Then it's formed just a tiny bit. Because it resists my attempts to be crimped directly in there. And that is not good. Wow, this is annoying. This is so freaking annoying. You have no idea how badly I want this to just be in place. So we can play with the printer again. Ooh. And that looks good. I guess we made it. I guess we made it. I hate crimping, but it's part of the deal. It's part of the deal. So, and if I can do this, so can anybody else. Also interesting here is that we need to now be careful with the polarity of the whole thing. And as I already said last time, well, actually it shouldn't really matter, but I'm just going to assume that the ground connection is the one closer. To the top. In the end, since we're just trying to check the filament switch, it shouldn't make any difference. There's no real polarity implied there, but having those cables match the direction of the voltage and current would be nice. Would be nice. Otherwise it's just a switch. Doesn't really matter. Either the switch is closed and your angry pixies can sprint from A to B, or the switch is open and they can't. That's all that is to it. Cool. Nice. Okay. I guess that is it then for Operation Fix the frickin' tool head. At least for the moment, because obviously we are going to move this tool head to some proper tech once we are done with testing and reviewing this printer kit. And the Hotend now becoming our first official mod here. A mod that seems to be required even on the later printers, because if you have seen the first reviews, that new sailfish Hotend seems to be a pile of garbage as well. Ooh, and there's somebody in chat. Hey Bella, thanks. I'm currently not in need of any designs. I will note down that you offered, and if anything comes up, I'll definitely consider you as one of the contestants. But yeah, at the moment, I'm doing this in my spare time. I'm not trying to earn any money with it. I don't think I ever will, because this is such a niche that it's pretty unlikely. So yeah, but thanks for offering. And I do want to, well, actually that's as far as this app goes in, so let's just screw that in. Let's avoid the squirrel here. I also want to try the originally designed filament path, to be honest. That kind of looks like a proper adventure as well. All right, that's on there. Now our two large screws still need to go in. With our Hotend mod, obviously, again pushing against us, especially since we now also restrained its cable. We might have wanted to hold off on that just a tiny bit. Oh, did I? No, I don't have a screw in there already. Oh screw, where are you? You probably see it on the screen, but I'm too blind to pick it up. You kidding me? Did I drop it or something? Interesting. Yeah, and just so you're aware, Jacob, if you're still in chat, but also for anybody else, you can catch this on either Twitter or YouTube. So feel free to use whatever you want. Oh, I see it. Whatever floats your boat. I'm there. not on TikTok yet. So, and I think people on TikTok wouldn't have a good time here anyway, since this requires at least a little space. But yeah, there you go. Ooh, and I know what I forgot. I completely forgot to turn on my new toys. What the hell? Because I actually managed to repair the arcade and managed to get the LED panel up and running and blinking as any broken LED panel would, right? Blinking like a gas halogen tube. So yeah, that's definitely realism here. Definitely realism here. Okay, so our tool head is reassembled. We have our Hotend connected, we have everything else connected. I said I wanted to try the filament path. One reason why I want to do that is because I want to, while this printer is then being recalibrated, which is something we need to do, I want to potentially mount the panels. So let's give it its design filament path and let's see what happens here. The way that works is you go through the top here. We can actually use the bend to hopefully be able to guide this somewhat to the side, and then in the inside of the foot has a hole that is I think about 4 millimeters in diameter. Where you can shove this in then. The important thing to note here is to not do this, to not make this too short, because you're otherwise going to drag the tube out the cable if you do. It's probably better to keep it a bit longer. And I should probably have taken off the back panel, but what's the fun in that? Where would be the fun in that? Yeah, I'm gonna take off the bottom panel. Put that back in place actually. And that is fixed in place. Let's turn this around. The reason why I'm taking the bottom panel and not the back panel is because the back panel is more of a pain in the ass. Bottom panel, of course, we're going to also get a quick look at the electronics in here, which might be a good choice and chance to, well, yeah, let's go for it. Let's go for it. This is actually our chance to also add the wiring for the Nevermore. And for that we should also take off the back panel anyway, so yeah, let's just not make our life harder than it needs to be. Move that aside. Move that aside. I didn't actually want to take you off, but alright. You neither, but okay, okay. And then we can take that off. Put that in its spot. The sharper you make any bends here, the harder it is going to be to print brittle filaments, so yeah, just look out for that. Otherwise, since this is PTFE tube, I'm not all that concerned about it running over things. The only concern I would have here is that it may constrain some airflow. To be honest, I really don't like how this is done. I really don't like how this is done. The way this tube doesn't fit well into this hole, and every time you want to shove filament in from the outside. I'm almost tempted to glue that in there, but it's PTFE tube. It's probably not gonna glue in there well. We'll have to see. We will have to see. Nah, I don't like this. I do not like this. what we can do here, of course, is add some strain relief, like for example add a cable tie to the bottom here. I think that's what we're going to do. The other way around. There we go. That gives us a bit of adjustability. Although I do see myself quite frustrated with putting a new filament, because this PTFE cable just doesn't want to stay in there. But it is obviously not meant to go through. Oh, you know what? You know what we're gonna do? Well, I'm actually going to try I don't like this at all. I'm going to try to first get that cut straight, because I think that might be one of the issues here. that it's not holding in place well. Oh, actually, that might have done the trick, because now that hole actually fits the whole tube, and that's sitting in there really well. Or at least well enough, so if I push in filament from the other side, this is not immediately coming up. It is immediately going to come out. Damn it. I'm going to add some glue. Just for good measure. And yeah, I really don't like this. This, by the way, being a Voron design, not a Fysetc specific one. And the reason why it's probably not well thought out is either because I'm completely misunderstanding what that hole is for. That is open on the outside, on the foot that was otherwise meant to be for the filament sensor and filament intake, or this is another idea here. This is not designed well. And by the way, I'm fiddling with the stream because I want to make sure that you're seeing things properly. There we go. Yeah, I still don't like how this is executed, but it'll have to do. It will have to do. So there. We also wanted to connect our Nevermore. And the problem with the Nevermore in this kit, just as a refresher, is that the kit does not have any 12-volt sources, but we have 12-volt fans in our Nevermore. The reason why we have 12-volt fans in the Nevermore is because we didn't use the Fysetc kit. The newer Fysetc kit actually comes with the fans for Nevermore. The major problem being that Fysetc has been notoriously bad at fans in general. So I do not trust them, especially with something of as vital importance as a filtering system. I'm not sure why they're forcing the new fans down our throat, but I don't think they're good. I really don't think they're going to be much better than the old ones. From the photos, they look just like the old ones, and while there may be some slight improvements there, I don't know. I don't know. Be careful. Be careful. We, by the way, are using Sunan fans that are able to, if I remember the specs correctly, push 13 cubic feet of air per minute, which sounds like a pretty decent fan. So yeah, I'm hoping that's it. I'm hoping that does the job. Oh yeah, we need to solder here. Let me move some stuff aside. Because we need to solder our... That's no good. I have 2 screws loose. There you go. Let's keep those there. Let's keep that here. Behind Bernie as well, I think is his name. The robot from the Lego robotics kit. And I only see 3 feetsies. Oh no, there is another rubber baby buggy bumper. Let's move those aside as well. Okay, then we need to get our soldering iron. The reason why we need to solder here is because I try to get a good crimp connection on these. So this is just to give you an idea of what we're going to do. This is a buck converter. It is 12 volt 1 amp out for anything between I think 15 and 85 volt in. We're going to connect that directly to our 2 remaining terminals here and directly to the Nevermore itself. So the thing will always be on. I'm not gonna bother hooking that up to any connection for now. Later, when we move to the Octopus, we're going to change that. We're going to change it to be controlled by the board and to be switchable by the board. But for now, it just doesn't make sense. Just the way it is. So what we need to do for now is we need to solder ends here. I was considering crimping them, but I don't think the crimp connections will hold up as well. So we're just going to solder them, and then we're going to basically take power from here, mount that somewhere here, or Or let me see here, just so we get an idea. So we can't actually mount it on the back side because the cables will be too short, and we have a lot of free space here. So we're just gonna stick that down. Ooh, that's also going to be rather short. That was kind of the plan before measuring. You know how those go. They usually don't. Yeah, something like that. Maybe put it down there. Or we could potentially also have these go out here and mount that there. Yeah, that's probably what we're gonna do. That's probably what we're gonna do. So we need to route these through here, round the back, and to here. So this is the distance we need to overcome, and then we need to have a connector on the end. That's going to be our solution. The cables themselves, these cables here, they are too thick to crimp them directly. We could crimp them with a bridge, but again, I don't think we would get very good results from that. So yeah, we're just gonna go with this and solder a bridge there. I mean, it's not like we're not able to solder anyways, and it's not a moving connection. If it was a moving connection, we would definitely need to use a crimped solution. And with moving connection, I obviously mean if there was some kind of drag chain involved, for example. Because solder is soft and rigid, or so you basically can just, if you have a solder joint, you can agitate it to break it. And that's not what we want in drag chains, but in this case it should be fine. So now the question becomes, where's my IDC plug? I had one on the back here. I'll have to lower my desk a bit. Oh, I'm completely blind. It was right in front of my nose. Here we go. And obviously you can't see a thing here, so let me move that aside. I'm just setting up the soldering iron because I got that out of the cupboard. I'm not currently soldering enough to warrant having that out on the desk. I'd rather have more space. So yeah, whenever I do need it, there's a bit of a process to it. But that's okay. That is completely fine. Yeah, by the way, I'm not sure if you saw that, but Fysetc did actually officially announce and showcase this the successor to this printer kit. I would suggest caution. There are some things in there that are better, but as I already mentioned last week, there's at least one report of a broken Wi-Fi connector that then destroyed the Wi-Fi controller on the board. So that in itself, not exactly the best thing to do. Not what you want to do, and something to look out for. My desk is too small. Yeah, so be careful with those. Be careful with those. Also, the Hotend seems to be very fragile. There are a couple of other things that need looking out for. Don't need that anymore. We will still need that. I'm just cleaning up a bit here because it is the chaos is getting to be a bit unmanageable. Yeah, but in general. Oh, and I like that as additional storage space. That's something to think about. That's definitely something to think about. In general, I would expect roughly the same quality as from this kit, plus a few things like the Nevermore and tap. Tap specifically in a CNC version, which means that it is going to be stiffer, but updates are going to be harder. And the Nevermore again. The hardware for Nevermore. And this is, by the way, something I went through with two Fysetc Nevermore kits before I just did my own thing. The way I figure it is there are kits that are good value and there are kits that aren't. Kits that are good value are, for example, I still consider this printer kit depending on what price you get it for, right? If you, and this is something where we're going to go into next week. or the week after. I do still consider this printer kit good value depending on which price you actually get it for. That's definitely a major concern here, is what's the price you're getting this printer for. If we look at kits from LDO or other vendors that have higher quality components, then compare it to this kit. The long and short of it is, if you do want to do specific upgrades to your electronics, to your Hotend, to your to other parts of the printer, and you know that already before even getting into the project, and if you're well versed in dealing with the problems of printer kits like these, so bomb in a box, no other features, or barely any other features. The Fysetc kits are even a bit more than, I would say, your blue rolls or your Funzer kits, because they already give you crimped wire harnesses, even though you have to recrimp those because they're shit. But yeah, in general, they're definitely niches, and if you're in a situation where you want to build a kit like this, but you just don't have the cash to build like an LDO kit, then yes, you're basically optionsless, and I would rather suggest to go for a kit like this than for a Funzer kit or blue rolls or any of the other cheaper variants. And I actually want to have more magnification here. I need to see a bit better because like my 3D vision is not the best. I hope you still get a good look as well. That looks pretty solid. Now for the other one. That should do. But I do want to heat shrink this. And in this case, we can probably just do the heat shrink with the iron. I don't like doing it that way, but I'm honestly too freaking lazy to get out the heat gun just for this piece. And we'll gonna use half a tube each. The thing to avoid if you do it like that is avoid using the tip, because then you're gonna spread all your solder over the heat shrink, and it's no fun. And don't try to keep the iron too long in one place too long, because you don't want to melt this. You only want to take advantage of its shrinking capabilities. So this, I think, shrinks at 130-ish. I don't remember the specs, to be honest, so don't want to say anything wrong here, but it should shrink at roughly that low a temperature, and also activate its internal glue. And that's it. I could also now sleeve this still, but I think we're gonna leave it at that. Next thing to do obviously would be to move back to the top camera and VHB this. So let's get that done. So there, that just should do just nicely. There we go. And now again, the frickin', oh no, actually, we're in luck. I found a corner that peeled off right away. What I'm gonna do though is I'm going to lower the desk somewhat, so I get a bit better access to the top of the printer, and I'm going to also move this somewhere else, somewhere in there. Oh, and we have a guest. We have a guest. Somebody's looking at me like he needs some attention. Let me see if I can show you this here. There we go. There he is. The devil incarnate. Hi. Hello. Hello. shoddy camera work. Hallo. High five. Jawohl, High five. Jawohl, Sitz. Fein. Männchen. Fein. Sitz. Fein. Rechts rum. Fein. Links rum. Fein. Verneigen. Verneigen. Mach's richtig. Verneigen. Fein. Sitz. Fein. Rückwärts. Rückwärts. Fein. Tanzen. There we go. Sitz. Sitz. Fine. And I think since he is in good boy mode, he did earn himself a treat now. High five. Jawohl. Bye bye. Bye bye. There you go. Anytime. I kind of owed you that one from last time, so all debts have now been paid. And yes, that was a quote again, but I'm not quite sure from where. I know that it was connected to some kind of witch and witchcraft, but I'm not quite sure where. Put it in the comments if you know. I would be guessing that it was something like Farscape. Farscape would probably be my first guess here. But yeah, who knows? Who knows? Before we get into TV series too deep, let's mount our buck converter though. The cabling got through here. The buck converter in there. And yeah, ideally that would sit somewhere completely different, but I don't know. In this case, especially since all cables are isolated here, and everything is neatly tucked in, I don't think we necessarily need to concern ourselves with this. The most important thing to remember though, when working with the buck converter, make sure you have the input be the input. If you ever mistake the input for the output, you're not gonna have a good time. You're definitely not gonna have a good time. It's just no fun. There we go. And let go over. Both of them are in the right orientation. And you're actually supposed to be on the other side here. Thank you. That does that. Yeah, again, if you want to do this as well, and you are unsure of how to wire this up, you need a buck converter on the second DC side port that converts your 24 volts here to 12. You could also put your buck converter on any constantly switched port. So let's say you have a port that is still running 24 volts, that is, let's secure that, that's still running 24 volts, that is black, 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 red, nicely done. That is VHB taped in there. That is really constant voltage, constant current. I would not suggest running your buck converter on a port that you also PWM switch. That is a bad idea. But a constantly switched one, like just on and off, or in case of a Clipper config 0 or 100%, that should be just fine. Then you could connect this directly to any of the remaining ports here. And by the way, I'm an idiot because now I will have to crimp these inside, and that sucks. But as you can see, they are long enough. Oh, and I actually needed to do it this way because I need to crimp them after running them through the back paneling here. Which probably not a bad idea. Actually, we might be able to get just enough room. No, we're not. Ooh, that is gonna be a pain in the butt. Let me show you. So we got our cable running here, and now we need to get it through this channel to the other side here, and then we can crimp it. I would not want to push the cable through here between the ABS sheet. And then we can actually use some tweezers to pull it out for crimping. Almost, almost. And I see we already have it almost 10. No, actually, first one was better. Here we go. That's workable. That's number one. That's number two. And now we can use some proper, non-stupidly small JSTs to make that connection. Yeah, let's see. There are my crimping pliers. JSTs. What a pain in the ass. What a pain in the ass these are. I think I'm hitting the front of the connector. That's probably making it not connect as well, not slide in as well. I might have to shorten this. Yeah, I'll shorten it. Like a board one. Well, no, it's actually pretty shoddy, but should be good enough. Should be good enough. There we go. Now our connector goes in this way, plus is on this side, so that is number 1. And that is number 2. And now we just need to get it into the port there, which is going to be a pain in the ass in its own right. And thank the universe for self-locking pliers. If you don't have any of these, get them. They are so the most useful tools you can have are things that self-lock, because they usually save you at least one hand, or at least a bit of your brain, because you don't need to concentrate on keeping things tight there as well. So what we're going to do now is we're going to add the bottom panel again, and then we're immediately going to test this, because we don't want to have open mains voltage on the bottom of our panel running anywhere close to us, obviously. All right, so safety first. Bottom panel goes back on before we turn anything on here. But on the flip side, closing up the whole printer and then noticing that those fans are not spinning would be slightly embarrassing. Just slightly, just slightly. Yeah. Also, before we close this up, I would want to quickly check on our tube here. Oh, that's pretty good. There we go. 2 left. Yeah, I decided to not do the filament sensor, but I may still go there if this connection turns out to be too shaky. I think I need another one. Let's go with the ball joint here, with the ball head screwdriver. Are you kidding me? Why are you not fitting? That should have been the correct one. Yeah, that is the correct one. Yeah, that just wasn't in there properly. Okay. So that is that filament path we cleaned up. The bottom panel is on there. So let's flip it. Let's get rid of this VHB tape. Just gonna be in the way. No, not you. And let's grab some power here. The power grab. And now, the big question. There we go. Both fans are spinning. And even though this is loaded with charcoal pellets, it is still pushing air out. So that's exactly what we want. Exactly how we wanted it. Nice. Yeah, okay. So turning that off. Returning the power to whence it came, and we're going to close this up and run printer calibrations. Here we go. Yeah, so we actually didn't finish our discussion on whether you are a good fit for this kit. If you're interested, my take on it is, if we really can't afford a better quality one, yes. If you want to make significant changes and you're not planning on relying on the electronics, which is a very smart move in this case, because the electronics here are both lacking in some regards as well as unsafe in some. That's a pretty good reason to get a different kit, definitely. Yeah, so if you really just want to build this printer, if you really just want to build this printer and you have the funds and you're willing to spend a bit more, I would likely go for the LDO kit. If you're flat out broke and bored, don't have a job and nothing else to do, then and you can barely scrounge around to find the, hopefully not much more than 350-400 bucks that this printer is going to run you, go for it. Go for it. That's just fine. Oh, by the way, the CNC tab, I'm completely stupid. The CNC tab is actually in the 2.4 kit. The V0 kit, the new one, is, I think, new Hotend, new catalyst board. With CAN bus, which, to be honest, I'm happy to see it, but I don't understand it. I'm happy to see that they actually moved to CAN bus from a technical point of view. But there's so many other things wrong with the catalyst board. Like, you're probably still not able to run 5 or 12 volt fans on your Hotend, for your Hotend or for your parts cooling, which would still make us choose a different board for the Hotend. So I'm not sure why that had to get more complicated for the sake of being able to say, yeah, we got CAN. We got CAN now on a V0. It's almost like it's a marketing-based move. I'm a big fan of CAN. We're gonna add CAN to this printer, but we're also going to completely exchange the electronics. So I'm not sure why that had to be there. Okay, so this is closed up. We have about half an hour left. What I would like to do right now is just recalibrate this on PLA and mount the panels, then print some more PLA, because obviously we need to, before we can reasonably say that we're ready for the Wilson basketball in a smaller format, obviously. But I also need to still, before I can finally review this and make up my mind on how good it is, we also still need to have a close look at how it behaves on high temp. So how well do the panels seal, and how well does the printer handle the additional temperature in the especially for the toolhead board and the electronics. Those are still two things I need to look at before I can review it. So I think it would actually make sense to calibrate it on ABS now. I mean, we got the thing. We can take those panels off whenever we want to print some more PLA. The question would be, what do we print in ABS? We'll see. We'll see. We're gonna throw on the panels. We're gonna throw on the panels, then we're gonna calibrate it. And I might even run input shaper still today, but I do need to be a bit mindful of the time. And I dropped something. Oh, there we go. Oh, why are you loud? Why are you loud? Where did I put the panels now? Where did I put the panels? Oh yeah. Found them. They were hiding. Let's put these on real quick. That looks like a winner. Winner, winner, chicken dinner. And I think I'm gonna move this table down a bit. So these are bottom. This is door. Still think that, and we don't need to necessarily. Oh well, let's just leave the panel in place. And one of my neighbors thought he needed to tell the whole world that he has a nice car. And this is just too far away from me. I need this closer. So I'm gonna just move it closer. Come here, you. We want you and you. Actually, let's put in both screws. Let's put that there. So you need to be here and you need to be there. Put that on. And neither of these screws are going in. That one's going now. What the hell? Yeah, I'm an idiot. I'm an idiot. It is late. I'm using the wrong screwdriver. There we go. That's in there. Now that also tells me that these go on the front. So we're gonna mount those there. And this would then not go there. That is probably... Yeah, that's a winner. Well, let's fit the top ones first. So this needs to go here. We need one of these. Exactly there, and one of exactly there. There we go. I think we can actually make it. Put this together and print something today. Just barely, but we may be able to. There we go, and now we need to get this right. So we're gonna have flat ones in the front as well. So this one there, and this one goes there. That does the trick, and somewhere there. I can screw that down. And that obviously jumped to the side. And did catch again, so I'm going to move you in the position where I need the other one. There. And that should do it. Now same deal here, you go here and there. That's fine. That's fine. By the way, the other reason why I am a bit hesitant to print ABS with this already is because I would like to have a good way of keeping a window open while I do. Sadly, at the moment, the weather is very cold and very humid, which is obviously bad. Oh yeah, and we still need to talk about amendments here. I completely forgot that. Yeah, so let's talk about that. First of all, during the last stream, I said that PLA and PETG are not recyclable. That's technically not true. The problem is more along the lines of, while these are very widely used in 3D printing, they're actually not widely used anywhere else. And because that's the case, recycling facilities are not set up to handle them. So while you can, of course, go and recycle PETG and PLA if you have processes in place, you usually don't have the process in place in the first place. Also, something to remember about PLA as a material is it's biodegradable, which is something it does not just do if hinted at or if in a proper environment, but it does so no matter the environment. It just does it at different rates. So let's say you use your PETG print for a length of time and you try to recycle it, then you're probably going to have a bit of a difficult time doing so, because your material will be degraded and not as well recyclable anymore. And that's likely why recyclers are not necessarily going to have a good time recycling that either. I mean, I know that Fabrik in Germany does have a recycling program. Don't get me wrong, there are people who do the recycling. But it is still somewhat hard to actually do that. The other side of this becomes apparent if you look at recycling PETG. PETG is a polymer that is made from PET and glycol. Now, there is no specific process to recycling PETG. What there is, though, is a process for recycling PET, your bottles and stuff like that, right? So And that process that works for PETG, provided that it gets depolymerized first. So you need to turn PETG into PET before you can recycle it in larger, or like that's the way that people at least suggest recycling PETG in larger quantities. And don't get me wrong, it's a good idea, but it requires effort. And since PETG, while widely used in 3D printing, is not as common yet anywhere else, and may never be, who knows? Who knows? We may never see a point where somebody actively considers recycling PET in the first place. And that's where the advantage of our standard materials is, like ABS, because we already know how to recycle those. We can use the same process that's used for recycling ABS from an automobile to also recycle our 3D prints. We can use the same pipelines, we can use the same cleaning processes, and like even the cleaning processes are probably, and by the way, please note, I'm not a chemist, I'm not a recycling expert. This is just research I've done on my own time, because I'm actually interested in doing recycling myself of 3D printing materials, right? I'm currently looking at shredding like shredding options. But I also need a shop to finally get my hands dirty on that, because I obviously can't do it in my nice but small workplace here, because I need that on a day-to-day basis. Yeah, but there basically at the moment there are a couple of hurdles that we need to overcome to even be able to recycle PET, PETG and PLA that are not present in the other materials. And those hurdles, while not insurmountable, but still present in the current recycling system, make it so that your PETG is virtually unrecyclable. Virtually, not literally. Right? It's not a material property. It is the problem of the process not being distributed enough. Obviously, if you have companies like Fabric doing it, then those companies can still recycle it. But I think they are inundated by requests. They probably have tons of material in their warehouses where people thought they would do something good by sending that to them, and maybe getting some kind of a discount on new filament even. And yeah, it's nice that you're considering that. But if you're not very religious with your failed prints, you're actually making that process harder, and you're even bogging down the pipeline of that recycling to some degree, which is, by the way, and this is something I do, and I think you should be aware of and should do yourself as well. every single filament, even every single separate color, because the additives in the colors do make a difference, gets a bag like this. Gets a separate bag like this, and whenever, I haven't had that chance yet, but whenever I get a chance to recycle my prints, failed prints, like objects I'm not using anymore, they all go into bags like this. They get their heat set inserts removed, and this will keep them clean. This will keep them dry, right? Dry is also really important if you want to extrude new pellets or want to extrude new filament. Clean, dry, and well sorted. And if you do that, then you can actually improve the recyclability of your failed prints, of your waste. But that's the only way how you can make this process, at least for the moment, in any way viable. And because your contaminated prints are probably much more of an environmental hazard, based on the fact that they need to be thoroughly cleaned in the first place. I mean, think of the cleaning solution you need for even extracting any contamination. So yeah, that's one of the amendments there, and one of the topics I think we've had now each and every stream, because it's really important to me to raise awareness of what happens to your prints, what you need to consider, how they can or can't be recycled. And really, with ABS prints, I would have no qualms just handing them off to a recycler, because it's a material that can be recycled well. Yeah, and I think that's actually the only, funnily, the only major amendment I need to make. The other topics were either not touched or reasonably solid, so kind of glad about that. Funny enough, though, I am talking to myself. All right. I think the first panels have been mounted. Love it. Love it. We're getting there. We're getting somewhere. The door is going to be a bit interesting, but that's actually something that I find really interesting about this printer specifically, is the fact that it has a top hat, and that you just can completely open up that top hat to give it room to breathe for PLA prints. Now I'm going to reference the manual here. Because I do want to know how those panels are secured on the bottom. Of the top hat. Let me see here. Yeah, that's what I thought. Cool. I'm an idiot. I obviously still need to add a nut here. There we go. Now the front. So there. And now the last side with the that ain't it. That is the piece you're looking for. That, and let's add the other one as well. No use delaying that. Did I just push that in there? Might have slipped out again. Oh yeah, it did. The bastard. There we go. There we go. Line that up. And line that up. Put that on there. Leave that slightly loose and then find the other side. If you're here or watching this after the fact, let me know how the music is. I'm interested in hearing your opinion. Is it too loud? Is it too distracting? Am I too distracting from the music? That's obviously better entertainment value than this stream will ever be, but hey, you're still here. Let me know. Let me know. This today more of a slower stream because again I don't have as much time and energy. I didn't have as much time to prepare for this stream today as well because I'm traveling tomorrow and a lot of that travel prep took my time, but I'm still interested in hearing what you think here. So write it in chat, or if you're seeing this after the fact, put it in the comments. While you're down there, press that like button, and if you're interested in seeing me again, or maybe not even me, but this project or other projects like the upcoming NXK3 project that will likely start somewhere in the middle of April when the printer arrives, or sometime in April when the printer finally arrives here. Yeah, let me know. Let me know. Otherwise, if you're interested in handhelds and want to follow the progress of me turning my ASUS ROG Z13, which is an ASUS attempt at a tablet, at an ROG tablet at that, how I am trying to turn that into a gaming handheld, because it, to be honest, like if you look at things like the ASUS ROG Ally or the Lenovo Legion Go, those are nice, but they do not have the power. The ASUS ROG Z13 has it. It also has more RAM, which is something I need for working on it, because I am a game developer and Unreal Engine is my thing, and that just does not care about your internal RAM. It wants a certain amount, and either it gets it or it throws a tantrum. So yeah, need 32 gigs. So those other devices were out. Had to go with the Z13. This looks kind of cool. I mean, I could have probably cleaned up the elephant's foot a bit, but yeah, that's fine. Guessing that goes there. Let's see here. What does our manual say? Yeah, basically the back pieces on the one side. Nah, wait, this side first. There we go. That's, I guess, for the other side. There we go. That's gonna do just fine. Now the back piece there, probably this. And then we have one of these. You can actually fill all three of these, I think. Just leaving the front one. Whoa. So there, and this one as well. And now we can hopefully push our panel in here. We may have to loosen these though. This also answers a question I had about this kit. whether you can or can't use VHB tape here, and not VHB tape, foam tape to seal this up. But I would guess that based on the fit, you would likely want to use different panel mounts to do so. You'd probably want them half a mil thicker for 1 millimeter tape, or like about 1.5 to 2 millimeters thicker or higher for anything else. I'm not sure it matters though, because I'm kind of guessing that there's not too much airflow. But that is also to be confirmed, and that's another project we're gonna do once we have the hardware. We're definitely going to look at the emissions of a 3D printer of different particle sizes, because that's another problem I think that needs to be solved. That's another problem we need to get a grip on to make 3D printing more generally available, is controlling emission of different gases. Many people from the 3D printing community are taking this topic very lightly. And I don't want to say too lightly, because again, I'm not an expert in the field. But I think the mentality that is currently being displayed, well, this is at least my personal opinion, the mentality that is currently being displayed towards that topic, because obviously people love their spare time activity, people want to get others into 3D printing, want to engage with them more about the topic even. That's all fine, but I think the side effects of 3D printing are not well known. They're not well known yet. Sure, we've dealt with plastic for many years now, and we should know this stuff. What the hell is going on here? But the way I see it addressed at the moment, might have some similarities to how smoking was approached, and the health aspects of smoking were approached back when that was the favorite pastime of people. And we all know how that turned out, how bad that turned out to be for you. Okay, so that actually does work. So yeah. Definitely fascinating, but I think should be handled with more care than it is currently. And I'm still 3D printing, so it's not like I think it's insurmountable or that the risks can't be managed. But I think there's also more risk than people realize. Because it's always that way. Especially if we like something, we tend to not always see the full picture. That is the door. So we got the other side door there. We got the other side back here. We got 1, 2, 3. Oh, that is kind of bad. Maybe not. 1, 2, 3. I mean, I could use that here. This seems to be the bottom. This is the other side of the door. And this is then the other side of the door, so we're missing one of these. We are missing one of those. Yeah. And this can either be no. Screw that down real quick. That's still loose. That corner piece is missing. We'll figure it out. Push comes to shove, this is something that printer can print for itself. There, that does that. Actually need to loosen that somewhat. Oh, damn it. Come here. And let's put in the panel. I'm really curious to see how well these seal. But for that to actually be measurable, we need a particle counter. We're gonna get one. We're gonna get one. Not sure when yet. But we are going to get one. And by the way, you don't actually need the manual there. So hopefully you see a bit more now. Kind of looking forward to printing ABS and ASA with this. And some nylon. Because those are the fast materials. There we go. And that didn't catch. Oh, because it slipped out. So there, and now the last couple screws for the big parts. I mean, I see that we have a nut preloaded here, so I think it's fair to assume that there's one of those middle pieces missing there. Oh. She was long gone. She was long gone. All right, all right. There we go. We have some door stuff left. Let's see what else is still in here. There's some more door stuff. There's at least one. Nice. Oh. Yeah, okay. So there. I guess that's it for the panels. We already got the magnets in the door locks. We now need to find them again to there we go. What we want to do now is want to make sure that we get the polarity right. We don't actually need to glue them in, because we're going to VHB the door on. So, and I think for this to work properly, we want to first close up this currently open top hat, so we have proper alignment, and so the no, that's not it. Oh, and we're already having problems here. So let's loosen those. Let's loosen those. One's in the back as well. So we can properly push this together as it was meant to be pushed together, with the extrusion completely sitting on the printed piece. And let's close this up on this side, so that's completely in there. On this side we still have a bit of a problem, I guess because of you here. Or because of the one in the back. Or that one. Might have been that one. In any case, we want things to be as freely movable as possible, so we can properly push them together. Otherwise our panels are not going to seal well. And that is definitely something I would like to avoid. Although I'm not sure how well the top hat's gonna seal in the first place. We'll have to see about that. So that's in there, that's on there. Nothing moving. Now I think I want to stabilize this, so it is actually So there. Perfectly stable construction.
He's coming out again for a new point.
Gonna go there.
Mark 4. Who wants the hard 4? 5 wants 4. Ace deuce scraps wants 4. 4 and he made it the hard way. Pay the front line, take the hard. We have a shooter and a good one coming out for a new point. Get your bets down, ladies and gentlemen. He's a rolling point as 9, place 9. He's shooting for 9. 5 shooting for 9. Who wants to come? 9 a winner. Got a hot hand. Place your bets, ladies and gentlemen. 6 the point. Place 6.
Well, actually, this shouldn't even be a topic. Usually you'd want to probably even adjust the anchor points here to fit the plexiglass, not the other way around. So we're gonna just VHB that on. It's a good thing we're on a cutting board. Let's see if we can get that a bit better. That's fine. It's also good. And now we needed the whole stream just to mount the panels. Wow. Oh well, it is what it is. Guess I could have done this off screen or off stream. Are you kidding me? Yeah, that's actually having this little lip there might actually help seal that a bit better. There we go. And yeah, if you haven't noticed, I stopped talking because I just want this done. I want to run a test print to see if the Hotend is working. Probably still in PLA, and then I want to go to bed, so I actually in somewhat of a decent constitution when I have to get on that train tomorrow. So so I don't mess it up. Because, and this is something I didn't realize before, that shit is expensive. It is actually, from where I am at the moment to London by train is more than 300 bucks. Even flights are cheaper. Even flights are cheaper. So I'm not quite sure why people even opt for this. And flights are faster as well. You fly, with all the hoops you gotta jump through and stuff. You're in the UK in under 5 hours. That's the time it takes me now to get to the connecting train. That even goes to Amsterdam. No, to Brussels actually. And from Brussels you get to then go to the UK via the tunnel, and that's pretty fast actually. Yeah, but it takes some time and some nerve to even book, because you have to go through multinational train systems. And funnily enough, if you don't know this, I am not sure how this is handled in the US and how many different train systems there are in the US. But apart from a couple of countries sharing train systems, each country basically has its own. There are a couple that really share their train system, but if you want to catch a train from like, let's say Lisbon to Prague, you have to switch in. Well, you have one track system in Spain, you have one track system in France, you have another track system in the Netherlands, you have to then switch to the German track system, and you finally, once that, and by the way, this fits beautifully, I just realized, once you're in Germany and you arrive in Dresden, they at the very least switch the engine to the Czech train system, which is, I think, the same that Russia uses, but I'm not sure. But that's basically the hoops you need to jump through to get from A to B in Europe, and it kind of sucks. And because that's already the case, it makes it hard to actually book a train to go from A to B. But what makes it harder is the fact that, of course, each and every country has its own train service. So And you can't necessarily ask one train service to book all of them for you. So in one case where we're now able to book our complete travel until Brussels from the German train services, but we do still have to book the Eurostar separately because they didn't allow us, or they didn't have a proper way of booking that, at least not online. You might be able to go to the counter and have them book you everything separately, but yeah, we still had to jump through quite a few hoops to then get one direction booked, and obviously we also need to book the other. Quite the pain in the ass. Quite the pain in the ass. But at least I'm making it to London again. Quite looking forward to that. Oh, and one other thing I really don't like about this whole journey. So of course I have to leave Anik here. And that, by the way, I don't get. Usually the ferry between, what is it, Calais and Dover, I think, takes foot passengers, but for some reason at the moment it does not. And I was kind of planning on just going by ferry, by train and ferry, and taking Anik with me. Oh, that's already on there. Yeah, but it was not to be. It was not to be. So Anik is going to meet a nice young lady called Eva, and is probably going to have a lot of fun with her, while I am going to his home country to, yeah, basically meet the team. Looking forward to that. Quite looking forward to that. A couple of them are typically joining these streams as well from time to time, and we see each other sometimes, but yeah. And I think one just dropped. Nope, it didn't. Well, yes, it did. Oh no, that's not even a screw. It's just dirt. So, let's put on that last corner here. And then grab our filament to secure the hinges. There we go. That is that. Now, hinges. Gonna do our tricky blocks here again. And we're going to... Oh, I'm an idiot. I am such an idiot. Make this straight. And I also need to move these magnets in place. Things are just flying around here. That's normal. That is completely normal. And let's get our escaping door back. We should be able to just put those in place. Nice. Now don't move them. I said don't move them. I'm not listening to myself, it seems. I am not listening to myself. Yeah, it's still good. Well, actually, they need to be spaced a bit further. Let's try that. Yeah. It's a bit lukewarm, the fit there, but these magnets, I don't expect too much from them, to be honest. They are probably just as cheap as the rest of the kit. And by the way, the construction with these magnets likely also only works well because the chamber is not heating up as much, which might be unfortunate for prints. in materials that like warmer temperature chamber temps. But the good news is that these prints are pretty small, so the effect that it should have should also not be as bad. We'll have to see. We'll have to see. It's definitely interesting. Oh, and 3x30 hinge bolts. Interesting. So they're actual bolts. And 3x30 bottom and 3x40 on the top. I think I saw some of those. These are the 40s. These are 35s. Yeah, there we go. I am pleasantly surprised by the amount of hardware that is left. Wow. Seriously? Is it a smaller one? Well, I don't know. No, don't do that. Let's just screw them in by hand. There we go. That one. And these, by the way, don't need to thread in any way heavily, just until they hit. They're not coming out of there. We could have done some wet and wild here, but I don't think it would be necessary or even a good idea, because at the same time that you secure that mechanism, you may also introduce something that hinders it. Hey, it's not worth it. Okay, so let's clean this up. That's pretty good. Pretty good as well. Set these on top. Whoops. And I guess, ooh, that's catching. Oh well. All right, so I guess we got it. I guess we got it. Put that aside. So there. These we don't need anymore. Screws we don't need anymore. Mouse we don't need anymore. Well, mouse we will need in a moment. Whoops. There we go. Let's fix the remaining things in place. All right. Okay, I like it. I like it. There you go. That's it. Fully assembled. All the features that we wanted are in for the moment. The filament path is in there. Everything else is in there as well. We're going to load the PLA. And we're going to do a PLA print. Although I think the spool holder needs to be mounted further up for this to work. Because otherwise the corner the filament needs to travel is pretty gruelingly tight, and it's probably something we want to avoid. And yeah, you know what? This stupid PTFE mount, not gonna do it. Not gonna do it. I need to be able to push the filament in from the bottom, and it needs to arrive from at the tool head, and the way that this is built at the moment, that's not possible. I need to have the tube come out somewhere where I need to print the version with the filament sensor. Otherwise, this is not gonna go well. It's just not, and that is slightly disappointing because I would like to not have that filament sensor there, to be honest. It's just a... I mean, why? Why the hell? So what we're going to do now is we're still going to set this up for PLA. We're going to leave the top head open. We are going to pull our filament out again. Spool it up real quick. So there, and yeah, I'm gonna take the back panel off. So yeah, this part of the printer build is not well maintained, and I'm guessing rightly so, because who the hell doesn't build this printer without the build this printer without the filament sensor? Here, me, don't like how this is designed. There could have been at least some fitting that keeps the PTFE tube in place. Like the thing that's there now, I don't think will ever work. I mean, it's not even deep enough. It's not even deep enough. So yeah, we're going to remove the back panel, take out our one silly little strain relief. See if this works again. Would be nice if it did. Yeah, there we go. Take out our one little strain relief here by just pulling that through. And then we're going to put in our old PTFE tube. I'm going to obviously keep this one. But our old tube did us quite well, and it does still fit through here. So there. There we go. Panels on. All of them actually, that makes me happy. Let's get that spool of filament back on there. And let's see. If we can at least get a PID tune for that Hotend here. Oh yeah, we can't actually close that. We cannot actually close that. Then we'll leave it open. I'm gonna leave it open. We want to leave it open anyways because of how PLA likes to be printed. And I'm just going to move the printer to the side here. No worries, I will get a camera on it so we can watch it print while it does. There we go. And then we need some power, so here's another little power grab. Whoops. And yeah, that is that. While that is doing its thing, we're going to just pull up our front end to reload that. What did we set here? Let's just quit workout real quick. Save that. And let me take you along here. While that does the PID tune, I will quickly walk you through the steps of securing your printer, I guess. Promise is a promise. And then we have a problem, okay. ADC out of range. Let's look at the logs. This might have something to do with our newly obtained sensors. No, I don't want the booking confirmation. Let's go to our printer. Oh, okay, there we go. And we want to look at our clipper log. That is far too small to be legible on the stream. Can we make it bigger? So, heater bed target 0, temp 24. Extruder target 0.1, temp 53. Minus 53. Now, minus 53 is a special kind of a value, because it basically means your thermistor is not connected properly. So I guess what we need to do is turn this machine off and disconnect it and have another look at our thermistor connection. Now, the thermistor connection itself was pretty solid as far as I remember. The question is, what could be the problem here? Do we maybe have a bad thermistor? Or do we just have a bad connection? By the way, this via screwdriver, let me actually move you to another view here. This via screwdriver I cannot recommend. It is basically falling apart already. I was hoping it would become my new go-to, but nope, not so much. Not so much. So, the heater connection. Let's do some pull tests here to see what shakes loose. That's in there properly, that's in there properly. The heater itself is mounted properly, I'd say. But for some reason, the MCU is reporting the connection as open. Now open means there's no connection being made, which means it could either be the crimp connections or a broken wire. How do we diagnose this? We have a special set of banana plugs here. Those banana plugs have DuPont connectors on the other side. And we have a multimeter, the venerable Fluke. Oh, that might not be a good idea. Don't throw the magnification glasses through the air. Anyways, we have a multimeter here that can tell us the resistance. Now, usually you'd want to use test leads because they're made for this, but in this case, since these leads are short enough, we're not dealing with high amounts of current. We can just use this directly. At the moment, the meter is saying we have an infinite resistance, obviously air, probably almost infinite, but as soon as we, I'm tempted to just lay you flat, little printer. It's gonna make it, it's gonna make it, it's gonna make it. There you go. Almost flat. Almost nothing in the way on this huge desk. Now, let's see what our connector says here. And indeed, that connection is completely open. That's unfortunate. because that means we would at the very least need to recrimp that. And if you remember correctly, I don't think I have another pin. I have the pins for this. I don't think I have pins for this. So first off, we need to depin this. Which in its own right means disassembling the bitch. Yeah. I gotta tell you, I am frustrated right now. I am majorly frustrated right now. I am pissed that I didn't see the misprint earlier. And I am frustrated about the connectors that are on here that I don't think I have any pins for. I'll need to order those. Well, let's just see if we can depin it where it is. Probably not, but maybe we're in luck. Ah, look at that. Let's see if these have a 0 resistance, if they have a resistance here. Oh, look at that. Shit. So these are fine. These are actually fine, so we don't need to recrimp anything. We just need to make sure that the connector works. Well, wait. That is fine. And obviously this needs to be working very, very well and very reliably to be trustworthy. So I just push that out the back. I think we didn't push in the connectors far enough. So there. Now let's attach this again. And what we can do now, just to verify this and see that it's working, is we can take off this board, obviously with the correct bit. And without the glasses, because those are a bit distracting. Where did I put that bit? I will need that in a second, so it would be somewhat bad if that was gone. Oh. I mean, I'm glad that I found the issue, but this mess ain't good. And I think my concentration is actually dwindling, so it would be awesome if I found it now. Exactly now. But I guess not. So this has the same bit. That's not going to fit there. Fuck. Oh, okay. Plan C. This has the same bit. And we're going to take off the tool head board here, because what we can do is, now that we know that the connector itself is fine-ish, we can check whether the plug is fine-ish by measuring its resistance on the back, and that gives us an indicator on if our connection is working as a whole. So we're going to disconnect these. We're going to get these plugged back in here, and then we're going to take our board here, spread it slightly, and you can probably not see that. Let me see here. So there's our board. We know that the upper row, the outer pins, are our connection, and we have a signal there. Nice. So we know that that connector works now. The question is still if that's enough for Clipper to boot up, but at least it's not a non-connection anymore. So let's get this printer into printing shape. Let's put it back together. I want you guys on that side. Thank you. I want my screw. And Ennick is somewhat anxious as well already. He wants his last big walk before we go our separate ways for some days. And I'm kind of curious how much he's going to like Eva. I mean, he's not Wally, so. Frecher Hund. A good dog, but a very naughty dog as well. And he needs to be for me to make good games, right? I could burst into flames. I really could burst into flames. Where the hell are my screws? I may not care as much. We can still add those. So, there we go. And I found my screws. They were very sneakily hidden. I'm guessing the same is true for the bit. So there. And the last one goes into there. And then we can try that again. See what shakes loose. There we go. That's in there. This is in there as well. That too. And that 4. That's good. That's good as well. Just close that for a moment. Guess it's easier to pick up. Now, we had one problem, and that's now resolved. And I also found the bit we were missing. It was under the frickin' printer. Directly under the frickin' printer. There we go. Let's try this again. Let's try this again. Let's go there. You can still see our log. Basically, the indicator we used here was the extruder temperature. And you can see the extruder here. It says target 0 and temp minus 53. That's obviously a problem. Now we're going to go back to our browser, reload this, and we're still seeing an ADC out of range. So let's check it out. Let's open our log, target, and now we're seeing minus 39. Oh, what the hell? Oh, what the hell? Let me try something here. Yes, move aside. And we're obviously need to restart our firmware as well. And I need to sit down because I'm absolutely pooped. There we go. Oh, and we have a visitor. We have a visitor. And look at that. Our nice little printer finally came back up. Now this is actually not a very good sign. We will need to have to check this and test this, but first, there's Enik. There's Enik. First, Enik is collecting his tags. The Enik tags, the dog tags. Oh. Oh. And I think somebody else was collecting tags on Enik. That's something we will definitely need to take care of pretty quickly once this stream is over. it looks like the dog got the first tick of the year. Good on him, because that means that he was somewhere where he had fun. And I know exactly where. I know exactly which bush is usually the one where he gets those. So yeah, we'll just have to remove that, but obviously not on the stream. I am going to reload this. And then we're going to PID tune. We're at least going to try this. Let me remove that. That's a different project. We don't want the slicer setup. We want the initial setup. There we go. Whoa. Some key had the audacity to fly off of my keyboard here. Let me move you back to this. And we're going to go to our printer here. I'm gonna go to the console, set the Let's find out what the resistance of our thermistor is supposed to be. interesting. This may be a PID tuning problem. This may also backfire really soon here. Let's see what happens. I mean, it looks good. Yeah, so there's definitely something wrong with this puppy. This puppy is definitely broken. We can see there that the, well, you can't, but I can feel that this is, there's definitely something wrong here. The Hotend is burning hot. The thermistor just showed a value that there couldn't be. This thermistor is not from this kit, by the way. It is I think from a different kit, from a different set, where I bought the thermistor and a 50-watt heater in conjunction. So I'm not quite sure. I'm not quite sure. What we can do, because I actually have 2 of those, is we can, for quick reference, measure the other one that we still have. Because it might as well be the thermistor that is broken here. Yeah, and that is actually something ish you would expect. 58, 85, 86 kilo ohm. The resistance sinks when the thermistor heats up, I think. So if I cradle this in my hand, it just moved from, and you can't actually see that. Let me see if I can show you this. So if you have your thermistor, you have your thermistor in connected to both leads, right? You look at your multimeter. The multimeter states something around the 80-ish K, which is room temperature, and then once you cradle your thermistor, it's supposed to drop, right? Because now it reads my body temperature, and you'd have to reference the data sheet of the thermistor to find out exactly what that means. Now, this is not exactly the case with our thermistor in the printer. So either that one's broken, that is one possibility. It should actually be a bit higher in value because it is cooled by the heater block, but who knows if that's actually the reason. There are a couple of things here. Oh, and I totally kinked the PTFE tube when I closed that. Might not want to do that. I might not want to do that because I could break the filament, and we don't want that. Let's maybe try to fiddle that out here. We're just gonna measure this again. See what values we're getting here. But I think it's our current connections, to be honest. May just go into put another agadaga on that, or iguduga, or however that's spelled. Yeah, here you go. It is again showing nothing. If I press the connection, it is showing 4 kilo ohm, which is way too little. It's supposed to be about 100 kilo ohm. So I think this puppy is bad. I think this puppy is just bad. I think we need to replace that. That is unfortunate. That is unfortunate because we're not going to do that today. I don't have a good replacement for that, I think. The other one is too short. And it's of the same type, so I'm not sure I want to trust it. So yeah, I will need to order another one, I think. I'm a bit disappointed because I was thinking we could get some more prints done, but you've seen me like exchange thermistors often enough now. Don't think we need to go through that again. So yeah, that's I think it for me for now. I'm gonna go for a big long walk with Anik before I go to bed to get up bright and early in the morning to get on the train. in the meantime. Thanks if you are watching this video right now. If you found something you found interesting, give us a like, share it, subscribe. I know it was a bit of a slower one, but we finally got a printer here. I'm gonna remove this element here. That is enclosed. Enclosed and ready to print engineering plastics. So yeah, looking forward to that. Looking forward to seeing this puppy spit out wonderful ABS, ASA and the like parts. In the meantime, thanks for watching. Again, share, like, subscribe. Let me know what I'm doing right, what I'm doing wrong in the comments. Let me know if the timing works for you, or if not, let me know what timing works for you, because maybe I have time then. I don't know. We're not gonna have a Monday stream for the Z13 build, because obviously I'm gonna be traveling. But next Saturday at 7 CES, no, it's CST still, so 7 Central Europe time, 6 UK, 1 PM East Coast, 9 AM West Coast. Catch a stream. Let's have some fun. Next week, definitely input shaper, definitely prints, definitely things to do. But yeah, for now, this puppy needs to go back on the shelf and needs to wait for parts. Nice. Yeah. So. Thanks for playing, I guess. And I will catch you in the next stream.